In this video, we're going to find the absolute maximum and absolute minimum of a function. F of x equals 2x to the 5 halves divided by 5 minus 2x to the 3 halves divided by 2, or divided by 3. Yeah, it's 3 halves. I need to write that a little better. Let's write this a little better here. So this is 2x to the 5 halves divided by 5 minus 2x to the 3 halves divided by 3 plus 2. So that's f of x. And they want us to find the max and min over the interval 0 to 3. So the first thing we want to do is we want to test the endpoints. We're going to plug in 0 into this function. And then we're also going to plug in 3 into this function, just see kind of what the y values are there. How high are they? How high or low are they? And then what we want to do is we want to find the derivative of this function. And once we find the derivative of this function, we'll set it equal to 0 to find the critical points. And when we find the critical points are the spots where we could possibly have extrema. And then we'll plug those into the original function and try and determine if they are maxes or mins as well. So f of 0, we plug it in first. We're going to do 2 times 0 to the 5 halves over 5 minus 2 times 0 to the 3 halves divided by 3 plus 2. You can see we get a value of 2 here. Do the same thing for f of 3. So we get 2 times 3 to the 5 halves divided by 5 minus 2 times 3 to the 3 halves divided by 3 plus 2. And you'll notice that we get, when we plug in 3, we'll get 2, let's see, 3 to the 5 halves times 2. Let's see, how do we want to do this? Let's split these two pieces into 2 times, let's see. This would be 2 times 3 to the 5th power to the 1/2 power divided by 5 minus 2 times 3 to the 3rd power to the 1/2 power divided by 3 plus 2. Okay, so then we can start to split this up. So 3 to the 5th would really be like 3 to the 4th times 3. So what's going to end up happening here is I'm going to end up with a root 3 inside there. Because if I take 3 to the 4th, and I'll write this up here. If I take 3 to the 4th times 3, that's 3 to the 5th, to the 1/2 power, I can actually take the square root of this piece right here, and the square root of 3 to the 4th would be 3 squared. So I'm going to end up with 2 times 3 squared, and then times, this would be, the square root of 3 would be root 3, over 5, and then minus, we're going to do the same thing with this 3 to the 3 halves. We're going to write that as, well, we already wrote it as 3 to the 3rd to the 1/2 power. We're going to write this as 3 squared times 3 to the 1/2, and the square root of 3 squared would just be 3. So we're going to end up with minus 2 times 3, and then root 3 afterwards, all divided by 3 plus 2. So then when I start to simplify this, I'm going to get 3 squared, which is 9, times 2, which is 18. So I get 18 root 3 over 5. Minus, this is going to be 6 root 3 over 3, but 6 over 3 reduces, these 3's cancel. So I'm left with 2 root 3 plus 2. So then I can go ahead and say that this is 10 root 3 over 5. So I have 18 root 3 over 5 minus, if I multiply by 5 over 5 to this radical, I end up with 10 root 3 over 5 plus 2. So when I subtract those two, I'm going to end up with 2. That'll be plus 8 root 3 over 5. So it's kind of a lot of work to get to this point here, but that's what we're going to get for our y value there. So we got a y value here of 2 when we do f of 0. We got a y value of 2 plus 8 root 3 divided by 5. I'm going to get the, let's see, we're going to take the square root. I'm going to get the decimal for this. So we're going to take the square root of 3. And then we're going to take it times 8. Divided by 5. Add it to the 2. So you can see that this one is like 4.77128. And this will help make our determination if this is an absolute max or min later on. So now that we've done that, let's take the derivative of f of x. So we're going to say f prime of x is equal to, this is 2/5. We bring the 5/2 to the front. That would be 5/2 times 2/5. And then we'd have x, if we subtract 1 from 5/2 here, that'd be 3/2. Minus, the same thing comes to the front, 3/2 comes to the front, so we have 3/2 times 2/3. And then we'd have x to the, subtract 1 from that, that'd be 1/2. All right, subtract 1 from 3/2. We're subtracting 2 over 2, so we end up with 1/2. And the derivative of 2 is 0. Now, you can see that these are going to cancel. 5/2 and 2/5 cancel. So we end up with x to the 3/2 minus, these cancel, I get x to the 1/2. Now, I'm going to set this equal to 0 to find the critical points. So let's do that. If I say this equals 0, and I start to solve here, maybe I should do that I'll do that in a different step. I'll say 0 equals x to the 3/2 minus x to the 1/2. So then I factor here, and I get 0 equals 1/2 when I factor x to the 1/2 out. This will give me factor out x to the 1/2. I subtract that out. I get x minus 1 in here, because I'm factoring out 1/2 out of this. That'd be 2 over 2 left. Use the zero product property. And I'm going to get root x is equal to 0, or x minus 1 equals 0. And then we're going to go ahead and take the square this side. We get x equals 0. Or add 1 to this side, and we get x equal 1. So these are our critical points. Now, we already tested 0 up here, so we don't have to test 0 again. So we're just going to test f of 1. So we're going to plug f of 1 in. And when we plug in f of 1, we're going to get f of 1, that'd be 2. And we're plugging into the original equation, 1 to the 5/2 over 5 minus 2, 1 to the 3/2 over 3 plus 2. So this 1 to the 5/2, that'll just be 1. 1 to the 3/2 will be 1. So we get 2/5 minus 2/3 plus 2. Let's go ahead and do that in the calculator. So 2 divided by 5 minus 2 divided by 3. and then plus 2. So I end up with, I'm going to use a decimal here instead of just writing this out as a fraction form. This is going to end up being 1.73. And the reason I'm writing out as a decimal for a second is because I want to compare this 1.73 with the 4.77 and the 2. So you can see that 1.73 is less than each of those. So we're going to say that 1.73 is less than or equal to 2, which is less than or equal to 4.77. So we can say that our absolute max right here on this interval would be 4.77. So this is an absolute max. And that 1.73 would be the absolute min. Because smallest on the graph. So we should probably write down those coordinates. So the coordinate I would have for the absolute min would be 1, and I've actually converted this to a fraction. So absolute min is going to be 1 comma 26 over 15. And the absolute max is going to be, we'll go back to the original here, it'd be 3, and then 2 plus 8 root 3 over 5.